everyone. In this video, we're going to talk about reflections in geometry. So a reflection is a transformation that uses a line like a mirror to reflect a figure. Okay, so basically you have a shape on one side of a line, you're going to flip it on the other side. So this is a congruence transformation. In other words, when we do a reflection, the shape stays congruent, has the same shape and the same size. This mirror line is called the line of reflection or the axis of symmetry. So that is the name of the line that we will be reflecting shapes over. All right, example one, we can reflect over horizontal and vertical lines, and we can reflect over diagonal lines. So in example one, we're just going to look at horizontal and vertical lines. So we're going to reflect triangle ABC in the line y equals -1. So we need to know what y equals -1 is. So if you remember from algebra, we can remember the acronym HOI, which stands for horizontal line, zero slope, y equals a number. So if we have y equals a number, then it's a horizontal line, and it's going to be a horizontal line through -1. So here's my line. I'm going to change it to a dashed line just so that we can distinguish it. Okay, so now what we're going to do, we're going to take the 3 points on our triangle, and however many points or however many units below the line of reflection that the point is, it's going to be the same number of units above the line. And if it's above, it's going to be below. So let's start with point A. So right now point A is 2 units below this line. So 1, 2, so point A prime will be 2 units above the line. B is 1, 2, 3 units above, so it'll be 1, 2, 3 units below the line, so B prime. And C is 1, 2, 3, 4 above, so it'll be 1, 2, 3, 4 below. So there's C prime. Okay, so now we can connect our points, and we should have our triangle. Okay, so notice, same size, same shape, we just reflected it or flipped it over that axis of symmetry. Okay, all right, so now a vertical line, x equals 1, so this is like Vux. Okay, x equals a number, vertical line, that U stands for it's an undefined slope. So x equals 1 would be right here, and let's change this to a dashed line or a dotted line. And now, however far these points are to the left of the line, we're going to reflect them, and they're going to be the same number of units to the right of this line. So A is 1, 2, 3, 4 to the left, so it'll be 1, 2, 3, 4 to the right, A prime. B is just 2 units to the left, so it'll be 2 units to the right. And C is 1, 2, 3, 4, 5 to the left, so 1, 2, 3, 4, 5 to the right. And we'll connect our points. And we have our reflected shape. Okay, so that's reflecting over horizontal and vertical lines. Now we can also reflect over diagonal lines, and in particular we can reflect over the line y equals x or y equals -x. So y equals x is a diagonal line, goes to the origin because the y-intercept is 0, and it has a slope of 1. So I'm going to draw my line here, has a slope of 1, so there's part of it, and here's the other part. Okay, so let's make these dashed again. And then we're going to reflect. So part of reflecting over a diagonal line is that when we reflect the point to the other side, the original point and the image point will form a perpendicular line to the line of reflection. Okay, so we can use that information to help us. So if we think about where A is located, if we were to draw a line like this to the diagonal line, we can kind of count how far we went there, right? So these aren't full units, but we can assume, or we can kind of, for our counting purposes, say like this is 1, 2, 3, like 3 diagonal units away. So our other point would be 1, 2, 3 on the other side, so A prime. Okay, so we can take those lines away. And now we can do the same thing with B. So B, notice, is like 1, but then just a half, right? So then we're going to go half and 1 in the other direction. So there's B prime. And then for C, it's kind of just half away, so it'll be half on the other side. And there's C prime. Whoops. All right, we'll just leave that little piece there. So now let's connect our points, A prime to B prime to C prime, and C prime back to A prime. And we have reflected that blue triangle over that diagonal line. Okay, And now for y equals negative x. So we're just going to go in the opposite direction here. So now our slope is -1, but we still go through the origin because our y-intercept is still 0. So we make these dashed lines, and now we're going to reflect these points. So notice A is on the line of reflection, so it's not even going to move. So that's still going to be A prime. B, we've got like 1, 2, 3 and a half. So half, 1, 2, 3. So B will be right there, B prime. C, we've got 1, 2 and a half. So half, 1 and 2. C will be right here, C prime. So now we've got A to A prime to B prime, B prime to C prime, and C prime, whoops, C prime, can't get my line drawn there, C prime back to A prime, okay? And we have reflected that triangle over y equals -x. So there are some coordinate rules for reflections over these 4 special lines. If we reflect over the x-axis, we're going to make the y coordinate opposite. If we reflect over the y-axis, we make the x coordinate opposite. If we reflect over y equals x, we're just going to switch our coordinates. And if we reflect over y equals -x, we're going to switch our coordinates and make them opposite. So we have some examples over here. So let's take, for example, a point 1, 2. If I was going to reflect it over the x-axis, it says just make the y coordinate opposite. So that would be the new point. For the next one, -4, -3, if we reflect it over the y-axis, we're going to make the x coordinate opposite. So -4 becomes +4. -3 stays the same. Y equals x says just flip the coordinates. And y equals -x says flip the coordinates and make them opposite. Okay, so we flip -7, 6, make them opposite, and we've got our new point. So those are some rules that we can memorize so that we know what happens to the coordinates when we do a certain reflection. Last thing we want to talk about with reflections is called lines of symmetry. So a figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection in a line. So basically what it means is, can you fold the shape and all the lines match up together? So we're going to look at 3 examples. How many lines of symmetry does each shape have? Well, we have a rectangle here where we could draw a line straight down the middle. So we could fold it kind of like, I guess we would say hamburger style, right? Fold it that way. Or we could draw a line down the center this way. I know my lines are not perfectly in the middle there, but we could fold it almost like hot dog style for there. Okay, so this shape has 2 lines of symmetry. Now for the next one, we have a regular pentagon. Okay, so notice if we draw a line straight down from each vertice, we could fold our shape over any one of these lines, right? So we have 5 vertices, so we're going to have 5 lines of symmetry here. So we could fold this shape over any one of those 5 lines, and they would lie on top of each other. And the last one for the triangle, we only have this one place where we could fold it, so there's just one line of symmetry. Okay, so that is reflections in geometry.